Okay, so I'm not sure whether we still have to give ourselves some few time, but then I think the time is already running and there's so much to cover. So I guess maybe we will just proceed with it as others join. So again, hi everyone, you're welcome to the interactive workshop section for this particular this year's symposium, which is the second annual Casted Fullerton ESG Public Health Symposium. So it's a pleasure to be here to actually lead in this workshop to give you some kind of introductory knowledge when it comes to the use of R for health data analysis, to be specific. So without much ado, I will just go ahead and let's try to go ahead and get something going. So first of all, let me stop sharing this. And so if you have already installed R, this is how you are going to see R on your desktop. So if you click on R, it opens. So there is R. So we have R and then we have R Studio. Now the difference between R and R Studio is pretty simple. It's just like having a car and now you are decorating the car, right? So you would want to make it look more nicer. I mean, if you are a fancy type of a guy. So, and that's what R Studio is about. So R is kind of the foundational ground on which R Studio have been built on. So you cannot install R Studio without first installing R. So that's the process. The process, it has to be consistent in terms of first of all installing R and then installing R Studio. Of course, you can use R to perform data analysis as usual as that of R Studio, and you shouldn't have any problem with that, right? But then, you know, we are in love with fancy stuff, right? Particularly given this kind of the century we find ourselves in, the generation of ours, we are all in love with fancy stuff. So we will just proceed to just go straight away to R Studio, and then maybe I'll give some slight introduction when it comes to the use of R Studio if you already don't know about R Studio. So if you have installed your R Studio, so okay, let me. So if you already if you open your R Studio, this is what you see. Sometimes it takes some time to come because depending on how fast the computer is. I hope my system would be very fast today. Okay, so now this is what we call, so okay. Sometimes once you open it to ask you to maybe update it, but not now, please. Okay, so now once you have your R Studio, this is how the R Studio actually looks like, where you have 4 different panels, right? And then with the 4 different panels, you have the source panel, you have the environment panel, you have the console panel, and then you have the plot, the package, and then the help, and then the viewer, and then other different information in which you are having here and the right bottom panel. So at the source panel, that is where, so the difference between the first R I open was the fact that if you type in the first R directly, then it becomes very difficult to actually save it. And assuming your computer shut down and you don't have the code existing, then you are going to lose everything. But with R Studio, even without saving, as long as you start typing in the source panel of the R Studio, should your computer shut down and then it come back, you open that R file, you should still be able to, if you open any R file at all, that section in which you are working on should also be able to pop up. And that's the good thing about using R Studio. So here is the source is where we are going to type in our codes. And then we have the environmental panel where you are going to have your variable and data and others collected here. So whenever you you call any variable or you introduce a new variable, whenever you call in your data set, all of them is going to find at the environment section. And then also we have this tab here where you are going to, whenever you display any plot, it is shown at this tab. And then also you have where you can also look at several packages of R. And then we also have help. When you need help to find anything about R, you can actually type in any information and then you should be able to find that. And then we have the console section, and this part is the interactive section where you can just, let's say, do some simple calculation, 1 + 1. I usually like 1 + 1 is equals to 2, right? So here you are just typing. Now the difference between performing your analysis at the source and then the console is the fact that if you type at the console and then you don't save it, you lose your code. But if you type at the source and then you don't save it and R shut down, you are still able to get it back. So that's the difference between typing your information at the source and then the console. So you are going to make use of the source. And then at the source, you have the run button where you can actually run every selected code. So, and then also you can use the button Control Enter to run any code. So for instance, if I say 5 - 2, right? And then if I hit enter, it gives me. But if I come to the source and then I put 5, let's say 5 + 2, then I can click on Control Enter and then it will be able to run. But at the same time, I can select it and then I can just run it. Or I can let the cursor blink on that line and then I'll click on run and then it will also be able to run. So this is just a quick introduction of what, when it comes to RStudio, what you think about RStudio and then its interface. So today we said we are looking at statistical analysis in R using a public health data set. So I wouldn't want to spend so much time talking about R function, how to perform function, how to define your own function. That is going to take us a hell of time, right? So what we are going to do, we are going to straight away dive into the data, and I'm sure that's something most of you are happy to see or interested in. So we are going to look at, first of all, how do we actually manipulate some data set in R. And then if you have already installed it, you can actually follow along whilst we perform some analysis. Now, when you have your information at the console, you can click on Control L, and then that is going to clear every information at the console, which is a free space for you to actually make any kind of output which is going to be printed out after you have performed any kind of analysis at the source panel. Okay, so now we are looking at data manipulation. So first of all, let's just look at this particular line of code, right? This particular line of code, what we are doing is we are going to define a particular variable, right? And then we are going to define that variable, we call it A. And that's how we define a variable in R. You can use any letter or any name, and then you bring the less than and minus sign, which represent the assignment function for R. And then you can put in any other information, and based on which you are telling R that whatever information that comes after the less than and minus sign, which is the assignment symbol, you are telling R that all those information, you are putting it into the variable at the left. So for instance, we said that A, and then also you can use equal sign. It doesn't matter if you would want to. Usually we prefer to use minus, the less than and minus, because there are times if you use equal sign, sometimes it can be confusing, given that equal sign can actually be used in certain function in which you might be performing. So let's make use of the less than and minus sign as the assignment sign. So we are going to assign A to some data over here. So we are going to use the C command. The C command is more or less like helping you to define something like a vector, right? So we are going to use a C command, and then also it's kind of going to concatenate information in which you are going to actually have for that particular variable you are assigning. So we said that A, then we bring the C command, and then we bring two brackets, and we put in all this information, right? And then after we have put in, now we can run that line. So again, you can select a particular information and hit on run, or while the button is blinking, you can hit on run and then we run it. So after we have run it, now we can, let's say, call our variable A. So we can call A and then let's say we run it, right? Or we can come to the interaction section and say, what is our A? And then we have run it. So now let us define another variable, right? So another variable, we are calling it X. And then we said that variable, again, we are using the C command, and then we are giving it this information within it, which all this information is within X. So now we can run that line. And then also we can call our X. So if you call our X is giving this information. So now we are going to, now if you look at the variable X, the variable X look more like, it doesn't look like a continuous variable, right? It looks like a variable that is categorical variable, or maybe you can say, think about a discrete variable, or maybe a nominal variable. So in that case, we want how to see it as a nominal variable so that we can easily make certain computation, right? So we are assigning, let's say, a particular variable B, right? And then we said that B should have a factor of X. Now the factor function over here, the factor function is allowing X to see that particular variable as a categorical or a nominal variable, right? So if we say that B is we are assigning B to a factor of X, then, so for instance, let me just do something really quick. If we take the summary, now in R, you can always use the summary to see the summary statistics of some information. So let's say we want to see the summary statistics for X. Now this is what we have. Now you notice that R is seen as more like a continuous variable rather than a categorical or a nominal variable. But we would want to see it more like a categorical or nominal variable with the number of how many ones do we have and how many twos do we have. And that's what the factor does for you. Okay.
Can I ask a quick request? My old eyes cannot see. Is there a way to make a zoom into that coding window? Or the left side, left half of the window at all?
Okay, let's zoom. Is it this? Or maybe I can now.
Maybe not. Maybe I just have to
I'm not
closer to the screen.
Yeah, I mean, I never used to zoom in, so yeah, I'm not sure, but
okay.
Yeah, I'm not
Thank
sure.
you.
Okay, sorry about that. Whoever is asking for it, yeah. Unfortunately, I'm not able to. Okay, let me see. What about if I use? Okay, yeah. Okay, there you go. I use Control+ on my keyboard. Okay. So now I think it's much better, right?
Yes, thank you.
Okay, all right. So now we can actually, so we would want R to see it as a nominal variable, right? So let's run. So we are now assigning that nominal variable of X to a variable B. So we can run B. And then now, remember that B contained the same information as X, but now X was not made as a nominal variable. So this was the information we have when we entered the summary. But we can also enter the summary of B, and then let's see what we have. Now we have R noticing it as a nominal variable, and we have 8 ones and then 5 twos. Okay, so now in the same way, we want to define another variable called levels, right? So our level variable, again, we would want R to see it as a factor, and then we are going to introduce the C command to put in all information we have for that particular variable. So first of all, we have our factor, then in a bracket, we then bring C, and then in another bracket, we put in all our information. Now we are using the inverted comma because it's a B, C, and co are string variable. Hence, you cannot just enter it. If you enter it, you are going to get some errors. So you have to use either a single inverted comma or a double inverted comma. So now there's our level. Let's run it. So now we run our level. So now we would want to form a data out of this, right? Out of this information we have. So we have information on A, we have information on A, we have information on B, which was a factor of X, which is a nominal variable, and then we have information on levels. But we want to put all this information together to form a given data set, right? So now we use the function called data.frame and then bracket. So data.frame, and then we use comma to separate the different variables we are coming to combine to form our data. So we have A, comma, B, comma, and then levels, comma. So now we are actually assigning this particular data frame to DF. So we are calling it DF equal this, right? So now we can straight away run it. Now, the good thing about assigning is that you are trying to save the information at your right into the left. So for instance, we could have just run only the data frame of the information and then we should have it, right? But the good thing is now, once we have DF is equal to this data frame, we don't have to run the entire of this information. We can just call DF and then we should be able to get our information. So now within the data frame, we can actually assign names or headings to the data frame. So for instance, we have A, B, and then levels, right? But we would want our A to represent age of the individual, B to represent the type type, and then we want the levels to represent what? Treatment. So we can just run, again, the same data frame, we can just run it, and then we can run, and then we can see the output is we have the age, type, and then our treatment. So now once you have this data frame, there are so many things you might want to think about. For instance, if you have a bigger data set and then you call in the data set, you would want to know what are the names of the variable I have in the data set. So you can use the function called names. So names into bracket DF actually allow you to know the names of the data set you have, right? So we have data, age, and then what? Age, type, and treatment. And then you can use head to get the first 6 rows of your data set or observation of the data set. And then you can use tail of so you know that we have head of our data, right? And then also tail of our data. So once you type tail into bracket, our data frame will form. And then when you run it, you are also going to see the last 6 information or observation of your data set. And then you can also use, maybe you would want to know the data for a particular variable within your data frame. So for instance, we have this variable age, type, and treatment. So we would want to know only age, right? So you can actually put in DF, because DF is representing our data set we form, and then you bring the $age. So DF $age means I want you to go into the data frame and give me only the age information on age. So by running it, we get only information on age. We can do the same thing for the type within our data frame, which is given that type has 2 levels, which is level 1 and 2, and these are the information of type. And we have this level simple because we already define that type as a factor, which now R is noticing it as a nominal variable. Then also we can do the same for treatment. And we can look at attributes. So the attribute actually allow you to know information, more information within your data set, right? So these are the attributes. So it gives you the name, the class, which is a data frame we formed, and then there are some row names within the data. Okay, so now let's move on to another step of trying to build on our data set, manipulating it in different ways. So we have a function called cbind, which actually allows us to combine different data frames, right? So for instance, I can have two different data sets, right? I can have one data set, df1, which I'm going to assign it to. I'm going to make it a data frame of only age and type, right? So I have data.frame of age. Now remember, we already defined of age equal A and then type equal B. Now you remember we already defined A and then B, right? So now R is already is able to make use of it. And then you can see that any variable we define is found at the variable environment panel of R. So now let us run this line. So we have df1, which is our new data frame we have formed, which is only containing age, which is equals to A, and then type, which is equals to B, which are the two variables we defined earlier on. And then we are forming another data frame, which is df2. And then we are only going to let it have one variable, right, within that data frame. So df2, so data.frame. Then we are going to put in the treatment, which is levels, right? And then we can run it. So again, if you want to see information in the data frame, you can just call it. So df1, we can come into the interaction part and then put df1. We are able to see the data frame for the data for df1. And then we have df2. We can also, and then enter. We are also able to see the information for df2. Okay, good. So now we can now go ahead and combine these two data frames, which is df1 and df2, to form one data set. So in order to do that, we use that function called cbind. In other words, combine. So you are just combining everything. So, and that's column combination. So you are combining the columns. So we realize that we have one column here, and then we have another column here. And before you use cbind, you have to make sure your columns have the same number of rows, so that R is able to actually perfectly understand what data you are communicating to it, right? So it should have the same number of rows, which before you can make use of the cbind. So okay, we are combining data frame df1, df2, right? So let's run this line, and then we are assigning it to a new variable called final data, right? So that final data, we said it should combine the column of the data frame df1 and the columns of data frame df2. Now let us run and see the final data and see. So this is our final data. Now I have successfully combined the two data sets. And that's how, when you think about being able to combine different data set of different data frame to be able to make use of, after you have collected different data from different sources, there's some function you can actually use in R to be able to combine your data. And then we can even, let's say we can run the summary of the data, and then to see age is a continuous variable. So we are getting the summary statistics for age, which is giving us the mean, the first quarter, the median. So in other words, the 5 number summary, and then we have type and then treatment, which were all nominal variables, hence R is given to us in this form. So one question one may ask is, what about if I want to combine the rows, right? So what do I do? For instance, maybe I've collected a data of some group of individuals, right? A data of, let's say, age, and then let's say age and height of, let's say, 10 students. Then I collected another data of age and height from another 5 students elsewhere. But it's the same data set. So how can I combine the data in order to have, let's say, 15 students within the same data? And now I can go ahead and perform my analysis. So in order to do that, let us try to define some data. And then before you make use of this, we are going to use a function called rbind, which is the combination of the rows of your data set. So in other words, it is going to combine observation or responses from observation within your data set, but it has to be collected on the same questions you pose to the individuals, right? So again, before you can do that, you have to actually make sure your columns are the same. In other words, it has to be age and height for this group, and at the same time, age and height for this group. If the column are not the same, then you might be actually putting a different data into another data set and performing your analysis wrongly. Okay, so now let us name, for instance, we want to name a particular variable. We are calling the student details. And in the student details, we are forming kind of a vector or a combination of a vector of this information. We are calling these the names of the students, which is Mark, John, Frederick, Floyd, and then George, right? So let us run it. Again, we are using the inverted comma because whenever you are writing a string variable, you have to introduce the inverted comma, and it can be a single inverted comma. Then also we have student class. So what is the class of? So if you look at here, we have student details. So we have Mark. So this is the name of Mark. Now there's the class of Mark. Class of Mark is high school. This is the name of John. This is the class of John. This is the name of Frederick. This is the class of Frederick. This is the name of Floyd, the class, and then in that order. So let us run this line of code. So now we have name and classes, right, of this individual. So now first of all, we are forming a data frame from this group of individual, right? So we are forming a data frame of student class and then their details, right? So now let us look at, we can run it. Now, once we have run, so again, you just use a comma to form data frame of several different maybe vectors you might define, right? So let us try to run the data frame and see. So we have this data frame. So we have the student class and then student details. So maybe we can decide to switch it for student details to come first and then their class to come next. That's fine as well. But let us keep it as it is. And then also we have another group of information that was also collected from other students, right? And now you realize that how many students we have here? We have 5 students, but we have another additional 2 students, right? So let's say this additional 2 students, we have their student details, okay? And then also we have their student class, okay? And then we are finding, and then one thing you should also notice is that when you use a particular variable to, if you assign information to a particular variable, and then you assign a different information to the same variable, R overwrite the previous variable, and then see the old variable as the new variable you are actually talking of. So just to put it in a context, now you remember, if you run student class, okay, let me, first of all, let me just do this one. So let's run this student detail, and then let's see the information on student detail we can run. So this is the information on student detail. Now, if I come and define another student detail, right? And then let us see the information on this student detail. So what do we see? Now, if we come here to run this student detail, R will still give us this new student detail because we will assign it to the same variable name. And so whenever you want R to see a new variable as a new information, you have to give it a new name. That's something you have to take note of. By the way, let's run this information, this true information. and then let us form a data frame and then run it. We have 5 students. So now again, we have student details for 2 students and then their class, their classes. So let us run it. So now and then we are calling that data frame RDF2. So if we run, and then we have formed the data frame from these 2 new students in which we collected their data, right? So we can go ahead and then let us run it. So we have the 2 students. So the question now becomes, okay, how am I able to combine these 2 students to these 2 students, given that it's the same information you have actually gathered, right? So in order to do that, you are going to use the R-bind, or the R-bind again is going to combine the 2 rows over here to the 5 rows we have here. So now if you go R-bind into bracket, our first data frame, which is the RF1, which is the first data frame for the 5 2 students, and then the RF2 for the second data frame for the additional 2 students we collect the data on. So now if we run them, this is the information. So we now have 7 students, right? Which now have combined the 2 students. So again, you can also use view to be able to view your data in a table form in R. So if you put view of our new data frame, which is RDF3, which was a data frame of combination of the 2 previous data frame collected from the students, you can use view. If you run the line of view, now I'll give it to you in the form of a tabular form, and then you can be able to look at it. Okay, let's go back to our code. So this is how you can actually combine columns and rows of a data just using the function cbind and then rbind. So now another also way to actually input data into into R is using, we have what is called read.data. Remember, the first information we were looking at is data.frame. But you can also use read.table to be able to actually read data into R as well. So for instance, let us name some information we would want to do over here. So we are going to name a new data called data. Let's name it data, or maybe we can call it, let's say data 1, right? And then we are going to use read.table. Okay, so read.table function. Then we did the read.table function. We are going to introduce the heading of our table. So we have header equal true, because we want the heading of the table. And then we have text. The text here is the data you are going to input directly into R. So text equal with then you bring 2 inverted commas. So if I can actually take off the entire of this data, and then, so this was initially, this is how it looks like. So now you have read.table header equal true, because we want to see the header, and then text equal. So now the text is where we are going to put in our data. So first of all, we have to input the header of our data, right? So we are putting the header of our data to be, how do you call it? Subject, sex, control, and then how do you call it? A control, condition 1, and then condition 2, right? So that's subject, sex, control, condition 1, and condition 2. So under subject, we have subject, let's say, represent student 1, right? Or maybe a respondent 1 to our survey. And then the sex of the individual is male, so we put M. Then we have the control of the individual, so we put 7.9. And then we have 12.3 representing condition 1, condition 2, 10.7. Now we can go ahead and continue to put in more data. So for instance, we have subject 6, and then we bring, how do you call it? You can introduce what is called the space bar. Subject 2, let's say subject 2 is representing female, right? Then we introduce the space bar, and the female is having a control group of a control of, let's say, some number, let's say 7.5, right? Then we can introduce another data on the condition. Let's say we have 10, and then here we have 4.5, right? Okay, so now when we run this, so you can input as many data as possible. And then we can now go ahead. You can select all of them, or maybe whilst the cursor blink, you can just run it. So now our data have been run. So now we can call our data by just, the data was called data 1. So with data 1, we can just select data 1 and then we can run it. So now we have our data. So we can input as many subjects as possible. And even we can also include additional column. So maybe we can include the additional column of information we have. Well, so this is how you can directly, how do you call it? Type in data into SPSS just using the read.table. Sorry, I say SPSS. Yeah, into, how do you call it? R using read.table. Then, of course, you can run the summary of your, how do you call it? Data, sorry. Now, again, you can see what happened. I have summary of data. I'll say, what data are you talking of? I'll say, I don't know that data. You haven't put in any data. But you can see we name it data 1, right? So R, there is nothing existing in R that is called data. So if you are running a code which doesn't exist, you are going to get, of course, an error. So we have to bring data 1. And then now we can run the summary, and then we have the summary of it. Okay, so now let us move to the bigger one, which is when you are actually making use of an ideal data set, which is going to be the data we are going to employ using, and the data which is actually existing in the website of the Symposium, if you have already downloaded it. And I believe it was also posted in the chat box. So now, in order to call a data set, and more importantly, a data set which is having a CSV file data set. Now, if you have your data set in Excel, you can actually change it to CSV file. And once you have it in a CSV file, you would want to call in that data set. So the data set we are going to start using is called the HINTS data set, which is the Human Information National Trend Survey, which is a population-based data set we are going to make use of. So we are going to call this data set, and to call this data set, we are going to use the function called c.csv. Then with c.csv, so first of all, we have this function. So I can take this out. So you have c.csv into bracket, then you can bring this information, file.choose, then comma, header equal t. T here means true. You can either write the true in full, or you can just write it. You can just write it as T, and R is still able to recognize it, but not little letter T. And one thing I didn't mention is that R is very case sensitive. So whenever you are performing R, small t is different from bigger T. So if you name a variable with small t and another variable with bigger T, they are totally different variable altogether. You are telling R. Okay, so now let me call, and then I'm naming this data I'm coming to call HINTS. You can give it a different name as you wish. So, but I'm calling it HINTS. Now I'm going to assign this HINTS to a data I'm coming to call into R. So I can run this line of code. Now, once you run this line, there's going to be a pop-up dialog box, which you have to notice. So there is a pop-up dialog box which has appeared over here. So in the pop-up dialog box, you can actually look out for your data set. So let me go into my data set, and I want to make use of this HINTS data set. Right, is the same, so I can double click on it. Once I have clicked on it, now the data is active in R. So now, how do I know the data is active in R? I can call the names of the data. So remember, the data have been named as HINTS. So names of HINTS, now it gives me the data. So now this is the variables or the columns of the data set I have. I have how many columns? 17 columns. So I have 1, 2, 3, 4, 5, 6, another up to 17 columns within the data set. I can perform a simple descriptive of the data set or see the summary of the data. And there's something which is good, because whenever you put in a data set, it's always good to actually perform a summary to know how does the data look like. Does the data have some missing variables? Does it have some information that doesn't have to be in the data set? So by just running summary of the data, it gives you a fair idea of what you have in the data set, right? So what do I have in the data set? I have the person's ID. I have and then these are some information you are going to actually see within the data set. So I have the summary of quality of care. I have summary of insurance of the patient or of the respondent. I have the age. I have the gender at birth. I have the full employment category of the individual, the marital status, the sexual orientation. But then what do we see? We can notice that we are having minus. Now, if I can actually show you the data, I think, let me quickly show you let me quickly share, how do you call it, the data information with you. Okay. Oh no, this isn't, I don't think so. Let me see. This one, let's see. Okay, so now if you look at this information, now this is the data which was given. These are the coded variables we have. Okay, so we have the quality of care is from 1, individual chooses from 1 to 5. We have health insurance, which is individual chooses from, is between 1 and 2, which is yes or no. We have age, which is continuous, starting from, I think, 18 years, because it's collected from adults starting from 18 years and above. We have gender, which is from 1 and 2. Okay, let me go back. And then in that form, but let me go back to the data. What do we see after our summary? We are seeing the minimum variable, the minimum value to be -9. We say, what? -9 is supposed not to be in the data set, right? So what the heck is -9 doing in my data set? So now it gives you a clue that no, there's something wrong with the data set I have to get rid of. And in hence, the way they coded the data is minus is representing missing variable. And in some time, it also represents multiple responses or even non-response. So these minuses within the data, which was not seen from the code I shared, has to be getting rid of. So how do I do that? Now let us look at this line of the code. Now, in order to be able to do that, I'm going to name a new data set, which I'm going to call it hence new. Why am I saying hence new? I'm saying hence new because I'm creating a new data. Sorry, I'm creating a new data set which does not include the negatives I have within the data set. And how do I exclude that? So now I'm going to, so with this hence new, I'm going to have hence, which is my original data set. Then I bring square brackets, right? So I'm going to say, let me just copy, let me just cut this whole stuff. Okay. So there's the first line you are going to, so you say that hence new, which is my new data set, but with my new data set, I want you to go to the old data set and pick this information for my new data set. So what information do I want to pick? So I want to pick this information. So I'm going to use, again, remember we always use the C command to combine so many variables, right? Or so many information. So I want to go into the hence, which is my original data, and then select the quality of care. Now you notice that we have hence $ quality care. So hence $ quality care means select only the variable quality care and then gives me all information about quality care which is greater than 0. In other words, we are eliminating every negative within the data set. I want you to do the same thing for health insurance. And then I want you to also repeat the same thing for age, because age can never be negative, right? So in case there's negative within age, I want you to get rid of the negatives. I want you to do the same thing for gender, because the gender was either 1 or 2, whether the individual is male or female. Okay. So now these are several variables. And then I'm using this sign as a means of combining the different data set I'm going to collect, which exclude the negative. Now, that doesn't also mean that information that is not found here, which are found in the original data, would not appear. All variables within the original data or columns within the original data is going to appear in my new data set. But however, those variables in which we said we are collecting data set that exclude the zeros, we are going to see them, and then we can perform a summary of which it excludes the zeros. So now we can go ahead and run this line of code. So let's run it. So once I have run this line of code, now let us see whether I have been able to implement that. So now we are finding the summary of hence new, which is the new data set. So let's look at the summary of it. Let us look at the summary of it. Okay, so now there's our summary. Let's see. Okay. So now let us look at variables in which were selected, right? Now you remember we said that it should give us variable for quality of care data greater than 0. So in our summary, we don't have negative anymore. Health insurance was the same, we don't have negative anymore, right? Occupation cut, full occupation was the same, gender was the same, age was the same. But again, if you look at it, we didn't include marital status. So now marital status still have the negative. So we can still go ahead and introduce some sign and then introduce this sign and then add marital status. So hence $ marital status greater than 0 now can also give us all a data which include marital status, which is beyond, which does not include negatives. So, okay, so this is the good thing about this line of code. Now allow you to be able to get rid of the negatives within the data, and that allow your data to be maybe ready for further analysis, right? Okay, so now let us also look at within our data set, we can actually recategorize certain variables within the data set. So for instance, let's assume that we would want to, within our new data set, which is hence new, we would want to create a new variable called age cut, which means age category. So we have hence $ age cut. It will introduce a new variable within our hence new data set. And then we are going to use this function, which is if else. The if else function is going to allow us to introduce the new variable. And we are using if else because we are coming to categorize age into 2 categories. So what are we saying? We are saying that, okay, within the new variable age cut, we want every age of the individual greater than, less than or equals to 45 to be coded as 0, and then 1 otherwise. So what it means is that for all the age group within our data, within the new column we are going to, or new variable we are going to create, it will go into the age column and then look at if there's any age value which is less than or equals to 45, it will now introduce 0 under age category. If it is not less than or equals to 5, it will give it 1. So now let us run it, this line, and see. Okay, so now we run it. And then we can look at the head of the data set. So let's look at the head of the data set. And now we have age cut within our data. So we have a new variable. Now we notice that if we can go all the way back to, you can see that we didn't have age cut as part of our columns. We just introduced it within our new data set, hence we have our age cut. And of course, you can use the names just to see the hints. And once you start typing it, usually I'll just give it to you. So we can just look at the names of the data set. And again, now we have 18 columns instead of 17 columns, which was the initial amount of data we have in our data set. Okay, so now, what about if I'm categorizing it into several groups rather than just 2 categories? Now, if else allow you to categorize it into only 2 categories. But now I want to categorize, for instance, let's take a variable like BMI. BMI is used in measuring the blood sugar level of individual, in other words, more importantly, diabetes, right? And then either the person, based on the BMI, we can conclude that the person is either underweight, overweight, obese, or normal, right? So now we are going to now tell R that, okay, within my data set, hence new, I'm now going to introduce a new data variable called BMI cut, because I want to now recategorize BMI, right? So BMI cut, but then with BMI cut, now I bring square brackets, okay? I bring square bracket. I want you to go into my data, which is hence new data, and go and take the BMI variable of the hence new data. And then for every BMI variable less than 18.5, I want you to name it as 1. So now we say that, okay, I'm creating a new variable called BMI cut with a square bracket. I want you to go into the BMI of the hence new data. And for every BMI, I want you, that is less than 18.5, I want you to assign it to 1. So now I can run this line of code. Then also I'm categorizing, I'm creating another new category of, again, BMI cut. So again, with the same variable, the new variable BMI cut, I want every variable that is less than or equals to any variable between 18.5 and of the BMI, and then 24.9, I want you to name it as 2. So between, there's how you can code between the variables. So I want, so between 18.5 and 24.9. So I said, okay, 18.5, I want that variable which is less than or equals to the hints of the BMI data. So in other words, I'm selecting every variable from 18.5 and above. And then now, and here means I'm now adding the additional group within that range. And I'm now bringing the BMI again. I want you to select every individual which is less than or equals to what? 24.9. And now I want you to assign it to 2 or code it as 2. So now R is going to actually code every value from 18.5 to 24.9 as 2. So now I can run this line of code. Okay. So now, similarly, I'm going to also assign another new value from 25 to 29.9, and I'm assigning it as 3. So now I can go ahead and then run it. And then also now, I'm now within the same new variable I'm creating, which is BMI cut, for every remaining data set of the BMI. Okay, let me, it has to be BMI, so BMI. Okay, so for every additional data set of the BMI, now I want you to name it as what? Give it 4. So in other words, now 1 represents people underweight, 2 represent those that are with normal weight, three represent overweight, and 4 represent obese. And this is how the standard way to recategorize the BMI. So now I can run this line of code. Okay, so now if I look at the head of hens, let me see whether hens have indeed introduced the new variable, which is the BMI cut, into my hens new data. So let me run. So now I have the new additional variable, which is what? BMI cut, which has now categorized every information we have under what? Under this BMI data set. So now I can also perform summary of it just to be able to know the summary of the BMI. So I have the additional value, which is the BMI cut as well. Okay, so now let us move on to, now with the current data set we have, there is no a missing space value, a missing space cell within the data set. The missing variable within the data set were coded as negatives, and that's why we have already eliminated them. But there are some data set in which you are going to see empty cells, and R see empty cells as NA. So for instance, let's code a new variable X, and let's assign this new variable X to a vector which is of 2 NA, 3, 4, 6, and then NA, right? So let us run it. Now we can run X to see what variable does it contain. Okay, so now let us look at summary of X. What do we see? We have NA, right? And how many NAs is R seeing? R is noticing 2 NAs. Okay, now let us try to perform the mean. Let's just say we just want to perform some statistic, which is the mean of X. So let's perform the mean of X. Oops. We are having NA. Really? Is the mean of this data set NA? Which is not true. But what is happening? Because of the existing missing data within it, the mean cannot compute it unless you are able to, you are able to tell R that there's an existing NA in it, and that now R is able to know the NAs, right? So now we are going to still perform the mean, but now we are going to introduce a command or argument which says NA.R equal true. So now within the mean, R is able to know that there is an existing NA. So it considers the NA and then eliminate the NA and then find the mean of the remaining values within the data. So now let us look at it. Let's run it. So now we have information, which is 3.75 as compared to the NA we had. But the question is, if I have a data set, how do I eliminate the NA? So we have this particular data which contains NA. How do I eliminate NA? You can eliminate NA using NA.omit function. So by using NA.omit, R is able to take away any missing data within that particular variable. So let us name a new variable X new. But for X new, we want X new to exclude any NA. Hence, we are using the function NA.omit. And then let us run it. Then we can run the summary. So now look at the first summary. This summary had NA. But in the second summary, we don't have NA, right? So this is how easily, now we can go ahead and freely, let's say, perform some statistic, which is the mean. Let's say we find the mean of what? Our X new. So the mean of X new, and then we can easily get the mean of X new, which is the same as the mean we had earlier on. So you can make this computation of the mean by letting R understand there is an existing missing data, or first of all, eliminating the missing data and then going ahead to perform your computation. Okay, so now we have been able to understand some aspect of the data set, how to combine data set in terms of the rows, in terms of the column, how to bring in data set, how to even directly input our own data set in R using the R.table to actually get data into R or physically, just like somebody will put in data into Excel or let's say XPSS directly. You can use the R.table to be able to do the same thing with R. Okay, so now let us now start thinking about performing some descriptive analysis or some descriptive statistics. So what are some? Usually there is a lot to talk about when it comes to descriptive statistics, but I'm going to try my best as possible to give you some descriptive statistics, including perhaps certain packages which you can easily use in performing certain descriptive analysis. So first of all, the first descriptive statistic you can think of is the simplest one, which is the summary of your data set. That is the first thing you can do for every data set you have you put into R. Again, that gives you a sense of what the data set looks like, right? So let's say we are going to now, from here onward, we are going to make use of our hence new data set, which is the new data set which excluded the negatives we have within the data, if you remember. So now we can perform the summary of it, and then we are seeing some summary, right? So those you see negatives, you remember those are variables, we didn't eliminate the negatives. But those you don't see negatives, we actually eliminated the negatives out of the data set. Okay, so but then you can perform, so we can see that from this summary, we can see we are having the 5-number summary, which is the mean, first quartile, median, the minimum variable, the minimum value of that variable, the first quartile, the median, the mean of the variable, the third quartile, and then also the maximum of the variable, right? So in other words, the 5-number summary plus the mean of the data set, right? But what about if I want to individually perform these statistics in R without having to call the summary of it, because I don't need everything, right? So what you can do is, so for instance, if I want to perform some descriptive statistics of mean of age, then I can actually say that, okay, I want R to give me the mean of age for hens of age. So now you remember I told you that we use the $ to call the data set. Now I can give you a quick look at it. So once I start typing hens, I can select my data set. And when I bring the $, R will give me a drop-down menu of all the variables I have within my data set. So I can select age. So now I can perform only the mean of age, right? But then there's also another way to do it. So rather than bringing hence new $, I can use with function, in which I'll say that with hence. So I mean, okay, go into the hence data, pick up and give me the mean of age. So with into in a parenthesis, the data set, comma, mean of age, I'm also going to get the same variable, the same output for the mean of age. Then I can perform other descriptive statistics like the variance by using just var, VAR, var of, again, hence $age. So var of age, the variance of age is given. I can find the standard deviation, which is SD of age. I can find the maximum value of age. What is the maximum value of age within my data set? So the maximum value of age is 100 years, right? What is the minimum value of age, which is 18 years, which makes sense because from the hint data, they collect data from individuals who are 18 years and above, who represent US adults, right? Then also I can get some quartiles. Now remember, in our summary, we were having some quartiles like the first quartile or the third quartiles. So I can use what is called the quartile function to be able to get some quartile for how do you call it, for age, which is going to give me the 0 quartile, the first quartile, the second quartile, the third quartile, the fifth quartile, and then so on. So let me perform some quartiles. So I have the 0 quartile is representing the minimum value. I have the 25 percentile, which is representing the first quartile. the 50th percentile representing the median of the data, the 75%, the 75 quartile, the 75% represent the third quartile, and then the 100% represent the maximum of the data set. Now, what if, okay, I want to actually define my own quartile or percentages, right? So now I can, within quartile, I can tell, okay, I want you to give me the quartile of the age within the Hinds new data, but then I want you to give me only the quartile for 30% quartile, which is 0.3, the 60% quartile, which is 0.6, and 90% quartile, which is 0.9. So now let me run it. So now I have 30%, 60%, and 90% quartile within my data set. So now I can also have the 5-number summary within the data set. And what did we say the 5-number summary are? We have the minimum, we have the first quartile, we have the median, we have the third quartile, and then we have the maximum of the data. And these represent the 5-number summary. So by just using the function 5num and then calling the data set, I want you to give me the 5-number summary within my Hinds new data of age. So now I can run it. And then there is a 5-number summary only, without any other information. Now, what other descriptive you might want to look at? What about if I want to know, I have a big data set, but the question is how many variables are in my data set? You can easily use what is called length of the data, and that gives you the number of variables within the data set. So let me give, so there is the length of the data, and that gives you, the number of, so this length of age is going to give you the number of observation of age, right? But then if I want to look at only for the number of variables within my data with length of Hinds new, it means I have 19 variables, right? But then if I want to look at the length for a specific data set, maybe length of age, then which again, it is going to give me the number of observation or respondent we have within the data set for age. And by running it, I can get, so this is the total number of respondents on age. So now I can use which.max function to indicate where in the data set is the maximum value of age located, or which observation represent the maximum age within my data set. So now I say which.max of what? Of the Hinds new $age. So it means that the maximum age is found with the 860 observation within my data set, or the row. If you go to the 861st row of my data set, that data set, the age of that individual is representing the maximum of the data set. What about if I want to know the minimum? The same thing, which.mean of my age, I'm also able to know. So it means that the 131 row or individual represent that very individual which has the minimum age within my data set. Now, what about if I want to know how many rows do I have in my data set for the entire data of Hinds new? So I can just use n row function. So n row into bracket Hinds, and then I'm able to see the number of rows in my data set, which is 2,888. 2,688. Then also, just as the length of the data gave us the number of variables within the data, you can also use a function called ncol, which is the number of columns within the data, to know the number of columns or variables I have in my data. So now I have 19 columns within the data set. Okay, so now let us move on to trying to use certain functions to perform certain descriptive. So for instance, what if I want to perform certain descriptive statistics for a particular nominal or categorical variable? Let's look at, for instance, birth gender or gender of the individual, which is representing either male or female, right? But I want R to give me the mean age for male and the mean age for female separate. How do I do that? You can use the function called tapply. So by using the tapply, we said that tapply, then in that bracket, we said that, okay, go to our data set, hence new. And then in that data set, we also have the birth gender of the data set, which is representing the nominal variable of the data set. And then also we would want to compute the, how do you call it, the mean of that data. And then you remember n.rm, again, which is going to, if there is an existing missing data, it can still compute the mean, even though there is a missing data, right? But so now using the tapply, my age, I want you to perform on this group, which is the gender group, male and female, and give me the mean of both male and female. So now, and then I'm assigning it to a new variable called mean age gender. And that then you can name your variable whichever way you want. So now let me run this line of code. So after running this line of code, now let us look at the mean. So now I have group 1, group 2, the mean and what? The mean of group 1, which is representing male, the mean of group 2, which is representing what? Female age. So these are the mean ages. Now there's also another function in which we can actually use to aggregate several and compute several functions of different groups. So for instance, I want to compute the mean for age, the mean for BMI, for both male and female. So I will use the aggregate function. So aggregate into bracket. Now I want R to go into the new, my hence new data. And within the hence new data, I bring a square bracket. I want R to select age and then BMI. So now I have selected BMI. And then I want you to give me the age and BMI for this list of, or for this group of variable, which is gender of the individual. And now I want to compute the mean. So what R is going to do is R is going to give me the mean BMI and then the mean age for both male and female. And by using the aggregate function, you are able to get all of them at the group. So let me run it. So this is what I have. So I have group 1, which is male and female. So this is the mean age for male, this is the mean BMI for male, and this is the mean age for female, this is the mean BMI for what? Female. Okay, so now we can also use a particular package to see several descriptive, which will include the number of values within the data set, even certain confidence intervals of those variables, and then others, some skewness, some ketosis within the data set. Sorry if there are certain terms you don't actually understand and I'm using them, but I will show you. I know some of you might have not heard about ketosis or something like that, but these are all extreme values within a data set you might think of. So you have to first of all install this package, which is called the passtext. So install .packages and then in an inverted comma pass dot. If you run it, you can now install the package. I have already installed it, so I wouldn't run it. But once you have installed it, you can now activate this package to use. If you don't activate the package, even though you have installed it, you cannot use it. So to activate the package, you use the function called library. So I can now activate the package. So once I have activated the package, this package is going to help me use this function, which is called stars.desc. In other words, that's stars.desc. In other words, the statistic distribution or description of some variables, right? So I'm going to perform the descriptive statistics for these variables, and we are going to see what are the statistics this function stars.dex is going to give us for each of the variables. And then remember, this description we are doing it for only continuous variable. You cannot do it for a categorical variable. And then again, it doesn't make sense to find the mean of a categorical variable or maybe a standard deviation of a categorical variable or a nominal variable. So whenever you want to perform a particular given statistic, you have to know which variable am I dealing with. So in our data, age is continuous, BMI is continuous, weekly minute moderate exercise is continuous, the average drink per week is continuous. So now with star.dex, I'm going to go into my hints new data. Then within the hints new data, I'm going to select these columns. Now there's something I want to show you in a very quick. Let me take out this. Now within your hints data, what you should know is whatever variable that comes here before the comma is a row variable or a row information. And whatever information that comes after is called column information. So I'm going into my hints data and then I'm going to pick these columns. I'm going to pick these columns. That's the column for age, and then I'm going to still use my C command to be able to get this all information. So I'm looking at the column for age, BMI, weekly exercise, moderate exercise, and then drink. So now let me go ahead and perform the descriptive statistics. So these are the descriptive statistics I have. Now you may not see it very well. Let me make it look very nice for you guys. But before then, we have this representing the number of value we have for age, how many of the variables are presented which are unknown, how many NAs we are having within a particular variable, the mean, the maximum, the range of the variable, the, how do you call it, the sum, the median, the standard error of the mean, the 95% confidence of the mean, the standard deviation, and then, so now it has actually run up this one in, it have used exponent to run it up. So let me make it nice. You can use what is called run, okay? You can use round. Let me take this out. Round means you want to run a particular data into a particular given decimal place, right? So with all this data I have, which is not nice, I cannot see it very well. I want how to run it to one decimal place for me. So to do that, I'm going to, let me see, so to do that, so I'm going to run what data? I'm going to run this whole data set I have, this whole information I computed over here, right? I'm going to run all of them, and then I'm going to run it to how many decimal place? I'm going to run it to one decimal place. Now, the good thing is I could have just say assign A to this whole stuff, right? I could have just say assign a variable to this whole stuff, right? And then I can now say that, okay, I want you to run A to one decimal place. And then I have it to one decimal place. So rather than having this whole function into the run, I just first of all assign it, and then I then use the run to run it to one decimal place. And by changing this to any value, you tell how the number of decimal place you actually want to run it. So now what do you see? For age, I'm having the number of observation for age, which is 2,688. Age have any null value or any non-response or any value which doesn't correspond with the data we are looking for. It doesn't have any missing data. So the number of NA is 0, the minimum, the maximum, and it's the same thing for all these other variables. Okay, somebody have a question.
I have a question. Can we do that by another variable like sex, like you had it before, using that package?
You said, can I do a different?
Yeah, so do the stat description by like sex or by a categorical variable?
By a categorical variable. So using this package, it only allows you to perform it on only continuous variable.
So you can't do the continuous variable by sex. So like among.
Yeah, if you want to do that, then you are going to use the aggregate function.
Oh, okay.
Yeah, if you are going to use the aggregate function, which is going to allow you to perform that by. But then with this,
it doesn't has everything though. Yeah.
It doesn't allow you to actually perform it for specific, put it into groups or different categories for a particular, let's say, nominal or categorical variable. That was a great question. Okay, so now that you have a good idea of descriptive, now let us look at some categorical variable descriptive. I hope there's a whole lot to cover, but I don't know. I hope I'm able to give you as much as possible. So let us look at now with a descriptive statistic for categorical variable. It's one of the simplest descriptions you can give. Usually it's just frequencies, right? But there are so many different frequencies you can have for a categorical variable. Yeah, but then just something quick I would want you to know. If you want to know more information about a particular function, you can use square root of, let's say, mean. So with square root of mean, if I run it, I'm able to see all information that is describing mean and any argument that I can perform in mean. And you can do the same thing for any other function. You can look out for, let's say, square root of star.dex and then see whether, I'm not sure whether maybe you can even perform a categorical variable within that star.dex, perhaps, maybe, by something, once you use the square root, you are able to know more about that particular variable. Okay, let's move on to categorical variable. So we are going to perform some frequency, but before you can perform the frequency, we are going to use a package called the summary tools. So first of all, you have to install the package and then you have to activate it. I have already installed it, so I'll just go ahead and activate it. And then frequency of what? Now remember, frequency, you can perform frequency on categorical variable. And we have the quality care as a categorical variable, where the individual will ask about their healthcare quality, ranging from excellent to poor. So we can perform the frequencies of care quality, and that's what we have. So these are the different frequencies we have. So we have, this is the count for each of the categories of care quality, their valid percentages, their cumulative percentages, their total percentage, and then their total cumulatives. So this is how quickly you can perform a frequency table of a categorical variable. And then also I can choose to not report the missing data, which is NA, for the frequency. And then also I can choose not to include the cumulative within the frequency. So by just adding comma report dot NAs equal false and then cumulative equal false, I'm able to eliminate that. So now if you look at here, I don't have the cumulative columns, right? So I'm only having the frequencies and its percentages. So another tool in which you can also use, which can actually give you a cross tabulation, right? Of now, remember, if you have two categorical variable, you might want to perform some cross tabulation to be able to see the percentages for the variable as it compares with each other, or you actually link it with each other. So you can use the function called cross table. But before you use it, you have to install this package, which is the gene models. So once you have installed the package, you can activate the package. And once you have activated the package, I want to perform the cross tabulation for health insurance. That's individuals were asked whether or not they have health insurance, and then also the gender of the individual, right? And then I want to actually have it to 2 decimal places, right? So with this, I can now, again, we say cross tab, health insurance, comma, birth gender, comma, again, using the $sign as a means to select that specific variable. So this is a cross tabulation I have, right? So this, and it is going to give it to me in the form of proportions, right? But maybe I would want to see it more like the way SPSS gives, right, which is in the form of percentages. So within the cross table function, I can now introduce format equal SPSS, right? So with format equal SPSS, and I want my digit to be 1 digit, which is 1 decimal place. And then I'm going to also name the columns, right? I'm going to name the columns. So the rows is going to be health insurance, and then the column is going to be the gender of the individual, right? So now let me run this line of code, and this is what I have. So I have insurance, I have gender. So gender 1 and 2, it is male and female. I have insurance, yes or no. So now I'm able to know what is the percentage of males who have insurance. Then I have to come here, right? And then have a look at the percentage of males who have insurance. And then what is the percent, which is about 41%? What is the percentage of females who have insurance? Then I have to come here. What percentage of females do not have insurance, and males who have insurance? And then we have, there is the total males, which is 40%, about 41% males, and then about 59% were females. So there's how you can actually do. Okay, now I think you are running, right? I hope you guys are following along very well. But let us look at data visualization, which I know is the fun part of most people. When they are seeing graph, they become very happy. So again, we are going to make use of this same summary of this same hence new data set. But we want to see some data visualization, and we are going to start visualizing a categorical variable. And to be able to visualize a categorical variable, first of all, we would want R to see that particular variable as a categorical or a nominal variable rather than just a continuous variable. So for instance, let's run summary and then see. If you look at the summary of quality of care, we are giving this 5-number summary, including the mean, which means R is seeing it as more or less like a continuous variable rather than a categorical variable. So how do? We introduce the factor. So now we are telling R, okay, in my hence new data, that same column of quality of care, I want you to now see the quality of care as a categorical variable. Hence, I'm introducing factor. So I say factor of hence of $ quality of care. So by so doing, R is now able to see quality of care as a categorical variable rather than a continuous variable. And I will explain to you, you will see in a minute the differences in the output of the summary when you see a categorical variable versus a continuous variable. I'm going to do the same thing for health insurance, and I'm going to do the same thing for gender because all those variables are categorical variables. So now let me run this whole stuff. So now I'll go back to look at the summary let me look at the summary, and then let me look at the variables in which we actually categorize them. So let us look at a health insurance. Quality of care was one of variables that were categorized. So now we have the 5 levels of quality of care, with each of them the number of observation, and the 2 levels of health insurance with each of them the number of observation. But look at the previous output. The quality of care was given to us in the form of 5-number summary, the same as the health insurance. So there's how I'll now understand by using the factor. Now you are dealing with a categorical variable for that particular variable. Okay, now let's run away and look at performing some graphs. So we want to first of all look at pie chart. Again, square root of pi allow you to see several information about how to compute our pie chart. So now, first of all, we want to form a table. Before you compute a pie chart, you have to form a table of that particular variable, right? So now we are going to form a table we are going to perform a pie chart for only quality of care. So we form a table of quality of care. So we are assigning it to a new variable called tab. And we are using the function called table. So we want to form a table for quality of care. So now let us run this code. And then let us look at our table. So we run this line. So now there's our table. So we have this, the number of individuals with excellent quality of care, very good, good, fair, and then poor quality of care, right? So now we would want to actually give some names, rare names to these 1, 2, 3, 4, 5, rather than just 1, 2, 3, 4, 5, because it becomes very difficult to understand, right? So we are going to add labels. So we are coming up with a new variable called labels. And within our labels, we are going to create these information, which include excellent, very good, good, fair, and then poor, right? By using C combined, so we can run it. So now we can now perform a pie chart. We are now coming to perform a pie chart of our tab, which is representing the quality of care. And then we are going to have the labels to be included, right? So there's a pie chart. So now you can have so many fancy stuff about the pie chart. You can add name to the pie chart. So by adding main equal, it allows you to add name to the pie chart. And then we can add some different colors to the pie chart. By default, these colors I'll choose for us, but we want to see more brighter colors like a rainbow colors, right? So we said that call equal rainbow length of our tab. So length of our tab means it is going to take, so let's run the length of tab. It's going to take give us the number of length of information of quality of care we have, which is 5 categories, right? But we can easily put 5 over there, but you can just make it length. Okay, now let us run this line. So there's what we have. Now R is able to give us what? A nice and beautiful pie chart. So what about if we would want to include some percentages within our pie chart, right? We would want to see some percentages. So because it's hard to say, okay, how many, maybe very good is the highest, but how many percentage very good do we have versus excellent and then so on. So first of all, to do that, let us define a new variable called pi percent. And then with the pi percent, we are going to compute the percentages. And how do we compute the percentages? We are going to compute the percentages, we are going to have for each of, remember how to find the relative percentage of a frequency. You take the variable, the count of the variable divided by the total, right? So now we have the tab divided by the sum of the tab. Now, so what it means is that I will go into the table. So first of all, let's look at our table. Just run only. So this is the table. So R will go into each of the table, and then now R is going to divide the table by what? By the sum of the table. Let's look at the sum of the table, and that is going to give you the total sum of the table. So now we are going to multiply it by 100 because we want it in percentages, right? And we have put in it in the round function because we want to see it in a 1 decimal place. So we are rounding it to 1 decimal place. So we said that round of 100 times tab divided by the sum of the tab, then run it to 1 decimal place. So we can run this, and then if we run our pi percent, this is what we have. So this is giving us the percentages for each of the quality of care, right? So now how do we include these percentages within our quality of care? So in order to include the percentages now, instead of the labels in which we have these labels, we are going to say labels equal, how do you call it, pi percent. So within our pie chart, we are going to find the pie chart of our table, which has the quality of care. And we want the labels to be equal to the percentages. And then we are still going to name it as the quality of care. And we are still going to introduce a rainbow colors, which has the length of our table. And then now let's run it. Okay. Oh, oops. Oh, okay. So let's run this line. Okay, so now this line has been run. So there's what I have. But then this one still doesn't make a lot more, it doesn't make more sense until I'm able to include some more information, which is going to tell me Okay, if we say 43% of what? We don't know. So we can have what is called the legend. The legend, and then within the legend, we can introduce some argument like, I want a legend of at the top right, and then the legend should give me the labels. And then remember, these were our labels, right? This was the labels we defined. And then the type of box. So this one is going to give me the size of the legend box, which is the CEX. And then also, I also still want to see within the legend, the rainbow colors to fill out each of the levels of the care quality, right? So let me run it. So now I have the legend of it. So this one make a more better sense of information we have, right? So now, also you can actually allow R to automatically install, install your, save your chart or your diagram on a particular, on your drive for you. But we wouldn't go much into it. I think I'll jump this section because maybe it might take some time. Let me go to another different stuff. So now you can also have a different pie chart, which is called a 3D pie chart. Maybe those of you who want to see a more fancy stuff. So I want to see a 3D pie chart. 3D pie chart, you have to install this package, which is called the Plottrix. With Plottrix, once you have installed it and you activate it, allow you to perform a 3D pie chart. And with a 3D pie chart, I'm going to perform a 3D pie chart, and I want the pie chart to explode. In other words, I want to see some gap between the pie chart, right? So with the same thing, and then so I want the same thing. It's never different from the first code we have here, but what is different is now we have installed it and we are going to introduce Pie 3D to be able to find a 3D pie chart. So we can now go. So there's our 3D pie chart. And by introducing the explode, there's how, so we can change the explode to, let's say, if we can change the explode to 1, we can see a bigger explosion, right? And there's how, and then we can introduce the legend just like we did before. So the legend, the same legend, we can introduce our legend, and then we have our legend here. So also let us look at, what about if you want to have a bar chart, which is also used for a visualization for a categorical variable, right? So simply to use a bar chart, we have the function called bar plot in R. You don't have to install any package to use the bar plot. So bar plot of what? We are still using bar plot of our tab. Remember, our tab is representing this, which is the quality of care. We form a table of the quality of care, right? So we are still going to make use of the tab to find a bar chart for. So there's a bar chart for the quality of care. Now we are having bar chart for the 5 different quality of care. Then you can also introduce some information within your bar chart where you can have the labels of the bar chart as well, right? So we can have names dot arg equal labels. Again, the labels is what we define, the variable we define called labels. And then X lab is going to give the name of the X, the horizontal axis, and then or the X axis, and then Y lab is going to give us the name of the Y axis or the vertical axis. And then we are going to color our bar chart. And then also we want to also color the border of the bar chart. And then we want to name the bar chart as the quality of care, right? So now let us run this line of code. So now I have this information. So now I have been able to change the X-axis of, and then the Y-axis of names as compared to previously when it didn't have names. And this is more informative, right? So, and then what about if I want it in a more of a horizontal, because there are times we see horizontal bar chart, right? So I want to see horizontal bar chart rather than a vertical bar chart. We can use this function. We can just add this function called the horizon function. And then we can say horizon equal true. Horizon equal false means we It's by default what we have now. But horizon equal true, then we are going to have it in an horizontal axis. But then you have to make sure you have to change the names, the y-axis and then the x-axis names. Because initially, our y-axis was the quality of care, but now so yes, we still have the quality of care, and then now our y-axis is x-axis is going to represent the counts, right? So this was the x-axis was the quality of care, but now the y-axis is the quality of care, and then so it has interchanged. So you have to make sure you name them accordingly. Okay, so also quickly, what about if we would want to actually introduce some frequencies within the bar chart, because we wouldn't want to see counts, we would want to see percentages, right? So to see percentages, we are going to use a function called prop table. So we are going to use prop table is going to give us the proportion for our for each of the categories we have in our variable. And then once we multiply it by 100, then we are going to get we are going to get the percentage of it. But we would want to run it one decimal place. So hence we put this whole information into run, comma, one decimal place. And then we are going to name it as a variable called rfreq, right? So now let us run it. And then if we call rfreq, if you call only that variable, we can see it is in one decimal place. So now we are now going to use rfreq for our bar chart, right? Rather than having a count. So now, again, we are also going to have the labels. We are going to have the label n names.arg equal the labels in which we defined earlier on. So we run it. And then now we are going to have we want to give a different colors, right? So we introduce call equal rainbow of 5. So we want you to give us any of the rainbow colors, 5 of the rainbow colors, right? And that's what I have done with the names and then star. Okay, so now what about if we also want to perform we want to include some labels. We want to see, rather than using eye inspection to think that, oh, excellent have about, let's say, 32%, which we are not sure. We would want to see the labels on top of it, right? So what do we do? In order to do that, we are also going to, we are going to name a new variable called the bar underscore label, and then we are going to let it to be equals to this whole function of bar plot. But then we are going to introduce lim. Lim over a y lim means we want, now you can see that over here, the limit is from 0 to 40. But we want the limit to be from, let's say, 0 to 70. You can change it to, let's say, 0 to 100, but we want it to be 0 to 70, right? And then we are assigning it to, so we are assigning this whole information, including a new argument we introduce into bar label. And then we are now going to call it. So now here is our bar label, right? Good. So I would tell you in a minute why we decided to assign it to a function, because by not assigning it, we will not be able to actually see the text on top of the label. Okay, so now let us come up with our legend. Again, the same legend as before. So we say our legend. So now we are going to use what is called the text function. So text bar underscore label, which is this one. Then we are going to say freq. So remember, this was our relative frequency in which we created, or the percentages, right? So freq of the relative frequency plus 0.5. That is actually going to allow us to center the list of the, allow us to center it over here under on the bars, right? And then we said the labels should be equals to what? The R freq, which is the relative percentages we created. So now let us run it. So now we have the percentages on top of it. Okay, so let us also look at, there's a stake. Okay, so I wish I can jump to inferential statistics, but I think also some people would want to know what about stake bar chart, right? Something like that. So let's quickly do something. You know, we have the stake bar chart, we have cluster bar chart and stuff and others, right? Let us look at something on, let's say, a stake bar chart, right? So a stake bar chart is you are using two groups of variable, right? Which are categorical variable, but you would want to put one group into the other group and then present it on the same chart. So let us now name a new variable. Since now we need two variables, we are going to name a new variable called, or a new table called tab 2. So tab 2, we want tab 2 to give us the variable for a table for quality of care and that of health insurance. So now let us run it and let us run. So now remember the first variable represents the rows and the second variable represents the columns. So the columns is representing the insurance, which is yes or no, and the rows are the type of quality of care of the quality of care. So now we would want to name this particular variable with a real name rather than 1, 2, 3, 4, so that we can make a very good sense out of it. So let's say we are naming a new variable called insure. And then with insure, we are using our C command function, and then we are going to have not insured and then insured. Let us run it. Then for quality of care, we are going to introduce a new variable called cal care. And then we are going to have all the type of care, right? Which is from excellent to poor. So let us run this too. So now that we have run it, now we are to have a bar chart. So we are going to have a bar chart of this tab 2, and that bar chart is going to give us a bar chart of quality of care by the insurance of the individual. And then we would want it to give us a bar chart based on the health insurance of the individual, right? But within the bar chart, it should give us for each of the quality of care for each type of insurance group of the individual. That's whether or not the individual was insured. So again, this names.add allow us to introduce the names for that particular bars we are actually looking at. And then we are going to have our X lab, which is the X label, and then the Y label. And then we are going to introduce our rainbow colors for the 5 counts of our quality care. So now let us run it. So there's what we have. So now for insured group and then uninsured group. So these are all the insured group, and for each of the insured group we have the different levels. So how do we include the level to make it more informative? Let us include the legend. So for each of the insured group, now we have the legends which have been included here, right? So this how, but then you can also, maybe another person would rather want to see columns for each of the type of quality of care, and then have it grouped by the type of insurance. So it's very simple. We just have to transform our data for tab 2. So let's say we have a new variable which is called tab 2 trans, and then we are going to use T to transform. Transformation means if it is a horizontal, it's going to make it how do you call it, vertical, right? Or if it is vertical, it's going to make it horizontal and in that form. So let us run it, and then let us run. So now you can see over here, it was the insurance was a column, right? But here the insurance are in rows. So now, once we can now bring in the, how do you call it, the tab 2 trans, and then also now, remember now, we are going to change the names.arg argument, which is going to be now the quality of care rather than the insurance, right? And then now, given that we want to see it by the type of insurance, whether or not the individual have insurance, we are going to have just a 2 color of rainbow, right? So let us run it. So now we have those insured and then uninsured, right? But how do we see it? So we are going to introduce a legend at the top right, and then we are going to have the labels to be insured, which is going to be these labels, right? Whether insured or uninsured. And then there's the box, and then there's the rainbow anyway. So we have this. So there's how you can also transform it. And this gives you pretty much similar information as the information we have earlier on. Okay, so let us, box plot is just straightforward, right? It's also, box plot is used for a continuous variable, right? So age is a continuous variable, BMI is a continuous variable. So let's say I want to perform, and a box plot gives us a sense of the 5 normal summary and distribution of a particular continuous variable. So let's say I want to perform a box plot of age, right? So you have box plot function, then you just put in the hence new of what age, you run it, and I just have the box plot. Now there are several arguments you can introduce into the box plot function, which includes Y labeled of the box plot and then also the title of the box plot. So now I can have this information given. And then of course, if you want your box plot to be a horizontal box plot, and even you would want to change the color of the box plot, you can use color equal to give it some color, or you can change the 2 to, let's say, blue, and you can have your own color. So by introducing the horizontal equal true, it now transforms our box plot in a horizontal version. So there's what we have, right? So now you can include some grid. Maybe you would want to see some background for the box plot, right? So by having this function grid, nx, which is the horizontal grids, and then the vertical grids. So nx equal null, y equal null. It is going to give us both horizontal and then vertical. And then you are going to see the LTI, which is going to give you the type of grid you want, the color of the grid, which maybe you might want a gray grid. You can change it to blue if you want. And then there's the length of the grid lines, right? Which we have L equal L, that's LWD equal 1. So let's run it. Okay. So now you have some great information in there, right? So now let us also look at, what about if I want to see, let's say, a bar chart for some specific group, like let's say, I want to see the age distribution for each category of quality of care, right? So with that, I will now run, let's say I will create a new variable called labels. And with the new variable, I want all the quality of care within that variable. And now I want different colors, right? So I want colors from red, yellow, blue, and then you have to put them in inverted commas. So I now name it as a new variable called call. Okay. So now I'm going to build a box plot of age that is going to give me the age distribution for each of the categories of quality of care, right? But I'm taking it from a data set, which is called the hence new data set, right? And then I want you to name the X label the X as quality of care, label the Y as the age, the years in age in years, give me the title as the age distribution by quality of care. And then I would want to also see some, how do you call it, rainbow colors, and then also some names in terms of some names in terms of the labels, right? Yeah. So I can just go ahead and then run this information. So there's what I have. I have different box plot, and then I'm having different colors. Now we have, I have to, very soon I have to wrap up. I think I have another meeting. I have to hop up very soon. But I'm sorry we couldn't cover everything we have, particularly when it goes to inferential statistics. I don't know whether maybe we might think of another workshop which has to do with that only part of inferential statistics, which I think students need it a lot to be able to know what type of inferences can I perform. Yeah, but then if you want to, you can have a side-by-side graph. And to have a side-by-side graph, you have this function, par function. You use the par function, and you have mthrow. Mthrow, it means within the mthrow, I'm using the C command. So I want two different chart of one row, two columns, right? So if you run this code, now I can run the bar chart I previously ran, which is this part. I'm going to run the same bar chart, but now I'm going to introduce something new within the bar chart by bringing just a comma, introduce something new, which is called notch, which is going to give you a different style of the bar chart. And this is called var width force. Bar width force is also going to actually make sure that the width of the bar chart stay the same. So now let us run. So every information else is still the same, but let's run. So now I have this, right? So there's the first column I have. Now I'm going to have the second column, but in the second column, I'm going to introduce the variance to be true. So in other words, it is going to give me different kind of shapes, right? Of this different group of bar chart for care quality. So now I can run it. And then also I introduce a new command, which is also called horizontal. So I have this information. And now you can see we have different shapes of the bar chart, which is showing the bar chart distribution for the plot. I wish I'm able to dive into the interpretation of the bar chart and stuff and others, but again, we are out of time. And I think perhaps we have to bring it to an end. And I'm sorry, there's a lot to cover, particularly the inference part, but I think we've come far in about 2 hours, I think. So at least you have a clear idea of when it comes to almost the data visualization aspect, and you can actually use histogram just to perform a simple histogram. For instance, maybe that's the last part we can do today. And then within the histogram, you can adjust it in any other way in which you want by just introducing some argument within the histogram function. Again, by using a question mark and then the help, question mark and then the function, you can know more about that function. Okay, so I think we will end here. Any question?
Thank you so much for your nice presentation. And I'll be really happy if you share any of the source while we can learn whole course of the R, and any suggestion for the student where they can get free R course. Thank you so much.
Okay, thank you.
Yeah, so I think I have a few requests to get the R code to be distributed to students, the ones that you use. So I told them that we would after the workshop ends. And then there's a question on the chat. I don't know if you're able to see it.
They say, from your experience, what are the statistical programming languages, R, blah, 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 okay, etc., that are most commonly used by organization for health data analysis? So it depends on the organization. Every organization, it varies from one organization to the other. And in an organization, sometimes you have, if you are a data analyst, sometimes you have the luxury to use a particular software you want, rather than, so you may want to either use R or SPSS, whichever software you are very comfortable with. But if your organization expects you to make use of SPSS, or maybe they've purchased SPSS for you and you think you are comfortable with SPSS, then of course you use it. But the good thing about R is that it is very interactive. You can make changes on your own as compared to something like SPSS, which tends to be more point and click kind of software. R and Python is pretty much similar. If you know R, knowing Python becomes very easy. And even just like also SAS, if you know R, knowing SAS can also become pretty easy as well. So, and then also given that R is an open source, and then R does not restrict you in terms of the number of, let's say, in terms of the perhaps the huge kind of data set you can perform, then I think you can always take advantage of R. But either way, each of the software you use, your results has to be consistent. Then also that the installation of R or of our open source and then limit the application of health data. No, it doesn't limit you in the application, so in accordance with.
There are web-based like Python and R things that you can run on a website. Those may go against HIPAA compliance if you're uploading data onto the web. So, but if you are running it on your computer and your computer is private and locked and password protected, then it would be a secure way of analyzing the data. But you don't want to upload it into a web to run it on a web, which is also a available sort of way of analysis, but that would go against the HIPAA.
Yeah. So I think I have to jump into my next meeting, which already they are waiting for me in a waiting room. So I think.
Okay, so I can try to answer the rest of the question.
Yeah,
thank you, Dr. Mamudu,
absolutely.
for the wonderful workshop. I took notes down, and I'm like, I need a copy of your stuff. So, and he had to jump out. So, just to answer about our course, there are like Coursera courses that are up there, but that are free. But you have to pay to get a certificate. But if you opt out of the certificate, you just want to learn the different R like modules, like it could be data inference or data visualization, you can definitely get that training there. And once we send out the code, another great way to get familiar is to kind of play around with it, right? Try different options, take something out, put something in. And that'll be, so using the existing code that we're going to send out, that's another way you can practice. And for the future presentation workshops, I think after today, we clearly realized that this was a lot of information in a very short amount of time, and we couldn't even get to the inference portion. So we are planning on doing more. And once we do, we will reach out through the email list that we already have to solicit any interest in future workshops. So thank you so much for devoting 2 hours of your precious time. I hope you gained some good analytical tools. I'm happy to stay for a little longer to answer any questions, but otherwise it was a pleasure to have you all.
Thank you so much. And for our CE credit, in which email we should contact? The email we got from your organization, is it the same email for CE credit? Chess credit?
For which ready?
For the credit option.
Oh, for the credit, yes, you can send the email to or email to me. I'm putting it in the chat right now. And I was told that I need the person's name and then your member information, but I'm gonna send out a mass email to everybody who registered with the instruction, and then it'll take probably a few weeks for it to get cleared, but we will get it registered and proper credit kind of allotted to everyone who came.
Thank you. And we'll be happy to get this recording, this session recording.
Oh, okay, for the recording too. Yes, we will have that available once we complete the workshop, and it'll take a few days now.
Oh, thank you. Thank you so much.
All right, thank you so much.